binomial theorem. Sometimes statements will be given. Otherwise, they will ask the question like state and prove binomial theorem for positive integers. Okay. Positive integers is nothing but natural numbers. So first we'll state the theorem for all positive integer n. For all positive integer n, a plus b power n is equal to nc0 into a to the power n plus nc1 into a power n minus 1 into b plus nc2 into a to the power n minus 2 into b square plus dash 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 plus ncn into b to the power n. Okay, this will be the statement of the theorem. To prove this theorem, we are proving this by using principle of mathematical induction. So consider the statement as P of n. So that P of n, that is a given statement, is a plus b power n is equal to nc0 into a power n plus nc1 into a power n minus 1 into b plus nc2 into a power n minus 2 into b square plus dash 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 plus ncn into b power n, writing the same given statement. After that, first step is let n is equal to 1. That is the first step in mathematical induction. LHS value is equal to, you can get a plus b power 1. Okay, a plus b power 1, that is nothing but is equal to a plus b itself. And go for the RHS. RHS value is equal to, see, while considering the RHS, n is equal to 1 means till 1 I need to take the terms. That means NC0 a power n and NC1. If n is equal to 2 means till where I need to take NC0 plus NC1 plus NC2 also I need to take. But here n is equal to 1 is there, right? So take the terms as NC0 into a power n. That means you can get 1C0 into a power 1 plus 1C1 into a power 1 minus 1 into b. If you simplify this one, it's equal to 1C0 value is 1, 1 into a is a, and 1C1 value is 1, a power 1 minus 1 is 0, that is 1 into b, so that I can get a plus b. Okay, now see, LHS value is equal to a plus b and RHS value is equal to a plus b, so that we can conclude, right? LHS is equal to RHS. Therefore, result is true for n is equal to 1. This is the first step. Then second step is assumption that we saw in mathematical induction. Assume that result is true for n is equal to k. Okay, so that the statement will become P of k is such that a plus b power k is equal to, wherever n is there in the given statement, see, P of n is there right here in this equation. Wherever n is there, replace it by k, so that you can get kc0 into a power k plus kc1 into a power k minus 1 into b plus kc2 into a power k minus 2 into b square plus dash 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 plus you can get kck into b power k. Take it as equation 1. So till a plus b power k we have the value, that is equation 1. And third step, see, actually in mathematical induction, in the third step we are taking let n is equal to k plus 1. First we are writing the possible results, after that we are proving that one, right? But here we are not writing the possible results, here we directly proving the k plus 1 term. So that third step is let n is equal to k plus 1. Okay, then see, consider LHS. What is LHS? A plus b power n place I need to substitute k plus 1. Okay, taking a plus b, LHS k plus 1, it's equal to, see, this can be written as a plus b into a plus b power k. Why? Because we have the formula a to the power m into a to the power n is nothing but a to the power m plus n. So a to the, you see, in place of a plus b is there. A plus b power 1 into a plus b power k. I can write it as a plus b power k plus 1. So that a plus b power k plus 1 can be written as a plus b into a plus b power k. In the next step, see, it's equal to a plus b into, what is the value of a plus b power k? That is nothing but equation 1, right? Here, see, a plus b power k, we have the right hand side value. Substitute that values so that I can write it as kc0 into a power k plus kc1 into a power k minus 1 into b plus kc2 into a power k minus 2 into b square plus dash 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 plus kck into b power k. Okay, just substituting k value in the above equation. Next is the very important step. First, multiply a to each terms in the expansion. After that, multiply b to each terms in the expansion. First, multiplying by a means all the powers of a will change. And in the second, if you are multiplying by b means all the powers of b will change. So that's it. It's equal to kc0 into a power k is multiplied by a, right, outside a power k, a into a power k, a to the a means a power 1, right? So that I can get a power k plus 1. So here kc0 into a power k plus 1 plus kc1 into, next see, a is multiplied to a power k minus 1. So that what you can get, it's equal to a power 1 plus k minus 1 plus 1 minus 1 get cancels. I can get only a power k, right? So next term is kc1 into a power k into b will remain same because power of a only change. Plus next kc2 into yes, k minus 1 because see a into a power k minus 2, it's equal to a power 1 plus k minus 2. So that you can get it's equal to a power k plus 1 minus 2 is minus 1, okay, into b square plus dash 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 plus the last term will be kck into a multiplied by a, right, into b power k. These terms are obtained by multiplying a to the sum inside the bracket. The next step, multiply the sum by b. Okay, multiplying by b, what is the first term? kc0 will remain same, no change in a power k, but I need to add one more b, right? kc0, see here, kc0 into a power k into b, kc1 a power k minus 1, what is the power of b? B square, right? Already one b is there.
Yes.
Outside multiplying by b, you can get b square plus, what is the next term?
Plus kc2
kc2 into
a power k minus 2
a power k minus 2
into b cube.
into b cube, okay, plus dash 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 here all right, dash dash dash. What is the last term? Plus kck into, you can get b power k plus 1. So the last term will be kck into b power k plus 1. Next, write the first sum same, no change, kc0 into a power k plus 1, no change, plus next see, group the terms. Here a to the power k into b is there in the first term. Here also see a to the power k into b is there. So we can say that a to the power k into b is the common term. So I can write it as see, here I'll get kc1 plus here I can get kc0. kc1 plus kc0 into a power k into b is remaining plus kc2 plus kc1 into
Into a power k minus 1 into b square.
b square plus, then no need to write other terms, go to the last term. Last term also remains same, no change, that is kck into b power k plus 1. K value, what is the value of kck?
1.
1. I can replace it by k plus 1 ck plus 1, right? Okay.
Yes.
Because the k plus 1 value is 1, kck value also is equal to 1. Another formula is NCR plus NCR minus 1 is equal to n plus 1 CR. It's a permutation and combination formula. Now see, first term kc0 into a power k plus 1 is there, right? I can write it as kc0 equals to k plus 1 c0 into a power k plus 1. Plus say second term kc1 plus kc0. Look at this one. It is in the form ncr plus ncr minus 1, right? 1 minus 1 form is there. Okay, ncr plus ncr minus 1. See like this, kc1 plus kc0 is there. How can you write this one? K plus 1 C1, right? Because see NCR plus NCR minus 1 is N plus 1. K plus 1. See what is the R value? This is R. This is R minus 1. So the second term I can write as K plus 1 C1. Together with that one, the number is A power K into B is there. Okay, plus K plus 1 C2. Along with that one, what is the term is there? A power K minus 1 into b square plus 1 c k plus 1 into b power k plus 1. Okay, or if you're not getting how to apply the formula, no need to write all these things. First write first term kc0 is replaced by k plus 1 c0 a power k plus 1. After 0 what will come next? NCC, look at this one, NC0 plus NC1 plus NC2, like this one, it will continue, right? So started by K plus 1 C0.
Yes.
Next what will come? K plus 1 C1. Next K plus 1 C2. Last term will be NCN means K plus 1 CK plus 1 into B power, you will get K plus 1. Here see A power will decrease by 1. A power K plus 1, then K into B, K minus 1 into B square, like this. Okay, and B power will be increased by 1. Okay, so just substituting values. So in the final step, we can write it as a result. Therefore, result is true for n is equal to k plus 1, and the conclusion is very important. Therefore, by the principle of mathematical induction, by the principle of mathematical induction, result is true for all natural numbers. Result is true for all natural numbers.